Okay, my last video of the day. This is my fourth one I've made in a matter of about 2 hours. So anyway, we are doing today solving equations over the complex set of numbers. In our last set of notes, we found the nth roots of complex numbers. The nth roots of a complex number. In this section, we're going to apply that to solving equations for all of the solutions, both real and complex. Remember, the fundamental theorem of algebra states that a polynomial of degree n has n solutions in the complex number system. So every fifth degree polynomial equation has 5 solutions, 5 distinct solutions, 5 different solutions. Every 8th degree polynomial equation has 8 distinct solutions, etc. Let's determine all solutions, real and complex, to this polynomial equation. Give your answers in reduced trig form, so we get to leave it in cis form. Okay? Alright, so I have x to the 4th plus 265i is equal to 0. That means that x to the 4th is equal to negative 256i. First thing I'm going to do is to write this in trig form. Write this in trig form. Visualize where that is located. 256i is located down on the negative y-axis, right? So what is theta? Theta is 3 pi over 2, right? So that would be 256 cis 3 pi over 2. We could write that in other ways. I could write that as a negative 256 cis of pi over 2. I like to keep my modulus r positive though. Okay, so my first thought is that I need to raise both sides to the 4th power, right? I need to raise both sides to the 4th power. But be careful when you write that, because this makes it look like there's only one solution, and there's not just one solution. There are 4 solutions. So I'm not going to write x equals. I'm just going to write that, and I'm going to go find my 4 solutions. 4 solutions. Okay? Alright, my first solution will be the 4th root of 256. The 4th root of 256 is 4. Cis. Multiply 1/4 times 3 pi over 2. And that will be 3 pi over 8. Now I know why they said I could leave it in trig form, because we cannot easily find the value of this. Okay? Plus 0, just like we did yesterday, plus 2 pi divided by n, and here is 4, right? Like that. Okay? 4 cis 3 pi over 8 plus 1 times 2 pi over 4. 4 cis 3 pi over 8 plus 2 times 2 pi over 4. 4 cis 3 pi over 8 plus 3 times 2 pi over 4. That will give us the 4 solutions. Now all we need to do is reduce those arguments. So we have 4 cis 3 pi over 8, our first answer. 4 cis, alright, I need to get a common denominator of 8. I'm multiplying 4 times 2 to get 8, so I multiply 2 times 2, so 4 pi. 4 pi on top plus 3 pi is 7 pi. Okay, now if I do this correctly, I should be 4 pi over 8 higher the next time. 4 pi over 8 higher. So this should be, if I add 4 pi over 8 to this, I should get 11 pi over 8. Let's see if we do. Okay, 2 times 2 is 4. But to get a common denominator, I need to multiply by another 2. So that will be 8. 8 pi plus 3 pi is indeed 11 pi over 8. The next one should be, if I add another 4 pi over 8, I should get 15 pi over 8. Let's see if I do. 6 times 2 is 12. 6, 7, 8. 12, 13, 14, 15. So, yes, 15 pi over 8. So these are the 4 solutions to the equation x to the 4th plus 256i is equal to 0. I find this stuff really interesting that we're able to do this. Let's determine all of the solutions, real and complex, to this one. Well, it's a 6th degree polynomial. 6th degree. That means we can have 6 distinct solutions. Distinct means different. So we're going to get 6 answers here. I already know what 2 of them are, right? Well, I take that back. I know, well, never mind. Let's just find them, okay? All right, so I have x to the 6th plus 64 is equal to 0. Subtract 64 to the other side, okay? Now I'm thinking to myself, I want the 6th root of this, but I can't do it unless I write this in trig form. So I'm going to write this in trig form. In trig form, where is negative 64 located? Negative 64 is located out on the negative x-axis, right? The negative real axis. So this is going to be 64 cis pi. And now I raise both sides to the 6th power. So in my mind, I have 64 cis pi to the 1/6 power. Did I say 6th power? 1/6 power. Okay? All right. So my first answer is the 6th root, the 6th root of 64 is 2. Multiply 1/6 times the argument and we get pi over 6. So I'm going to start my pattern. 0 times 2 pi divided by n, and here is 6. The next one in the pattern. Pi over 6 plus 1 times 2 pi over 6. 2 times 2 pi over 6. 3 times 2 pi over 6. 2 more. 4 times 2 pi over 6. 5 times 2 pi over 6. Okay? So we have 2 cis pi over 6. 2 cis 2 pi plus pi is 3 pi over 6. That's pi over 2. 2 cis 4 pi plus 1 pi is 5 pi over 6. 2 cis 6 pi plus 1 pi is 7 pi over 6. Next one's going to be 8 pi plus 1 pi is 9 pi over 6. That is 3 pi over 2. And then lastly, 2 cis 10 pi plus 1 pi is 11 pi over 6. Hopefully you remember that from what we did yesterday, or the last time I left a video, which was, for me, about 5 minutes ago. Okay. So now we need to write it in reduced standard form, so a plus bi form. So we'll have 2 times cosine of pi over 6 is square root 3 over 2. Sine of pi over 6 is a half. That's going to give me just square root of 3 plus I, right? 2 cis pi over 2. 2 cis pi over 2. Well, I could think of that as, it's cis pi over 2. If I think of that on a graph, cis pi over 2 is up here. That's just 2i, right? That is just 2i. Or you can work it the long way. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. That is either way 2i. Cosine of 5 pi over 6 is negative square root 3 over 2. Sine of 5 pi over 6 is positive 1/2. So this will be a negative square root of 3 plus I. Cosine of 7 pi over 6, negative square root of 3 over 2. Sine of 7 pi over 6, negative 1/2. That's going to be a negative square root 3 minus I. Cosine of 3 pi over 2 is 0. Cosine of any pi over 2 is 0. Sine of 3 pi over 2 is a negative 1. So this gives us a negative 2i. And cosine of 11 pi over 6 is a positive square root 3 over 2. And sine of 11 pi over 6 is a negative 1/2. So this is a positive square root of 3 minus I. So my 6 solutions of 6 to the 6 plus 64 is equal to 0 are square root 3 plus I, 2I, negative square root of 3 plus I, negative square root of 3 minus I, negative 2I, and square root of 3 minus I. 6 distinct solutions to that 6th degree polynomial. What would happen if we graphed that, you guys? What would happen if we graphed that? Let me pull out my... I didn't bring home my colored graphing calculator, but I do have this one. Let's graph that and see what it looks like. X to the 6th plus 64 plus 64. Oops. If I graph it right now, I'm not going to see a thing unless I change my window. If I just do zoom 4, I won't see a thing because this is way up high to 64, right? So what I'm going to do is I'm going to change my window. Actually, I think I'm not going to change my window. I'm going to, this is the graph of x to the 6th shifted up 64, right? So it would be this graph shifted up 64 units. Does it look like it has 6 distinct answers? No, it does not look like it. It looks like there is one answer here of just 0, right? But there are 6 distinct complex answers. Okay? All right.